Hello everyone. So the walkthrough we're going to go through today is the MalwareTrafficAnalysis03. Let's take a look at the challenge details and let's get started. The attached PCAP belongs to an exploitation kit infection. Analyze it using your favorite malware tool and answer the challenge questions. What is the IP address of the infected Windows host? Now to find this, I actually went into Brim Security and I've already typed in the alert here. And the answer I found was this one right here, 192.168, because everything else is not a local host. As well as we can clearly see there is malware talking to it under the alert signature column here. So answer to question 1 is 192.168.137.62. Question 2. What is the exploit kit EK name? 2 words. So to do this one, I want to make sure we cover it again. That the exploit kit is actually going to be this here, called the BDEEP. We're going to go BDEEP Network Trojan, and in our second link here we have Trojan BDEEP description. Except all, it's fine. And we're going to see it is actually part of the payloads of exploit kits. And if we scroll down even further, we'll see the answer right here: examples of exploit kits, Angular EK. This goes into a whole description of what this exploit is and how it works. So our answer is Angular EK. So, question 3. What is the fully qualified domain name that delivered the exploit kit? Now, what we're going to do, so bring up my notes, is we're going to open up the file in Brim Security again, and I want us to take a look at this IP here. So this is the IP that is the important one, or you can actually check all of these and you'll eventually find this as well. That if we take this IP and put it into Wireshark, and we go to statistics and then resolved addresses, wait for this to show up, there it is, and we start typing in that IP, the 192.99, we'll see it here actually, and that is our answer, qwe.mv.net. We minimize all this, we can bring this back up here. You can see our answer, qwe.net. Question 4. What is the redirect URL that points to the exploit landing page? So what we're going to do is we're going to open up Wireshark, and we're going to search for our malicious website again, the QWE. And we're actually going to find the answer right here, lifeinsidedetroit.com, whack.php. So, question 5. What is the fully qualified domain name of the compromised website? Now, what I've done is there's a tool you can use called Packet Total, and I've uploaded the file to this. And in the first timestamp, we can actually find the answer right here, the HTTP ear surgery. And based on the 3 different answers we have from before, what it really looks like is some sort of watering hole attack where one website got compromised. Ooh, look at my hand. And one website got compromised, which then led to an attack from another website. This is clearly looking like a watering hole attack. Okay. Question 6. Which TCP stream shows the malware payload being delivered? Provide stream number. So, what we're going to do is let's open up Wireshark. And I'm going to put in the search that I had before. So, the IP that we're searching from, the source, is where the malware came from, and then the destination is our local network here. And on top of that, we're also going to search for the website that we had before, the qwe.net. So let's filter it up first. Okay. Now, if we hit it once, we'll jump to packet 2775, and I'll show you why this is the wrong answer. We go to HTTP. We can see this is in clear text. This is not a payload. This is just a whole bunch of text, and then this is just a bunch of random garbage that isn't needed for anything. If we go to the second one, go to the filter again. Right to the left. Okay. We're not going to go to the first one. If we go to the second one, and we go to the HTTP stream, this is the one that is actually suspicious, because although this is just ciphertext, this is just encryption, this here is the part that's the actual malicious part, and you're going to see this show up more often, or you're going to see this show up again later in this little lesson. And you can also see it down here. So the fact that you're getting this constantly repeated text is the one that's highly suspicious, and we can see right here, TCP stream equals 80. So if we go back to here, we can see which TCP stream shows the malware payload being delivered, and it is port 80. What is the IP address of the CNC server? So command and controller C2 server. Now for this, we're actually going to go into Wireshark, and we're going to go statistics, conversations. And what I want to see is, I want to see the most amount of conversations that is being connected with our infected IP, which is 192.168 there. So I'm going to put the bytes at the top, and I've already gone through a lot of this. So what I ended up finding is that this 209 is the answer, and the reason I know it's the answer, because I popped all of these IPs into Brim Security as well. And if I pop this in, you will see that we're going to get a notice. When I double click this notice, we'll say, hey, the SSL invalid cert. Now the reason this is invalid is because a lot of C2 servers connect over 443, which is HTTPS. HTTPS is how you the S part is secure, but they need a certificate to verify. C2 servers operate on a domain, but the domain isn't real. So they have to have a self-signed SSL certificate. And when they self-sign, that's how you kind of know, like, hey, this isn't real, something is going on here. Now, in some cases, user may connect to it, but in this case, this is actually the C2 server, because there is no network of trust. So if we go back here, what is the IP address? It is 209.126.97.209. Question 8. What is the expiration date of the SSL certificate? So this question obviously leans in from the one from our previous question, question 7, but the way we're going to find this is actually pretty interesting. So what we're going to do is we're going to go bring up our previous IP again, the 209. We're going to open up the SSL. And there's going to be a server name. And I don't know how to pronounce that because that's just not English. I don't know what that is. So what we're going to do is we're going to take this, we're going to copy this, and then we're going to go into Network Miner. And check this out. If we pop this in here, we're going to see the .cer files, and this is the certificate file. If you open the file, and we go to details, it will show us right here, valid to November 24th, 2024. So 11/24/2024, but the format that's asking for is day, month, year. So 24 month 2024. All right, question 9. The malicious domain served a zip archive. What is the name of the DLL file included in this archive? Now, this is actually a fun one. I'm going to show you how to do this. So what we're going to do is going to export objects. We know it's over HTTP from our TCP 80. And what we're going to do is we're going to take our previous web domain that we found, the QWE, and I've already exported all these on my first go through this. This obviously is just a walkthrough. The one that we're looking for, let's bring it back, is the XPF. And what we're going to do is we're just going to save this. I'm going to put this in my folder here. You can see this is when I went through the first time, all these different files. And I'm just going to call this file 11. Close that. Open up our folder here in the same domain, or same directory. And here we have the answer right there. DLL. Ooh, my hand's still weird. So, question 10. So we're going to answer question 10 and question 14 at the same time here. So let's do this. Extract the malware payload, deobfuscate it, and remove the shellcode from the beginning. This should give you the actual payload, a DLL file, used for the infection. What is the MD5 hash of the payload? Question 14. What is the CVE of the exploited vulnerability? So, what we're going to do is let's extract the piece of malware first. We're going to go to our Wireshark, HTTP, and what we're going to do is we're going to use the previous website as before, the QWE, and the one we're going to export is the octet stream. going to save this. And I'm going to call it file2, file02. Cool. If we go to our file here, fantastic. So I want us to get the strings of this as well, just so you guys can see it is the same piece of malware from before, how we saw all the same repeated code. You'll see what I mean when I bring it up here. And we saw all this in the TCP stream from before. Now the reason this is important, because if we keep searching through the malware and keep Googling this malware, I searched through an enormous amount of blogs to finally land on this one. It was malware don't need coffee. And we can see here in Angler, each exploit has its own XOR key. And this is it right here. And we can see this is the same text that we just saw in the malware. So if I open up our virtual machine, open up Kali Links, we can see it is that right there. So what it means is that in order to decrypt this, this is the key. And this right here is the question to answer 14. Actually, I'll bring it up real quick to show you. Answer 14. So let's go back. We're going to open up, now we don't need this anymore. So we're going to go back to our folder here. And what we want to do is we want to take this and we're going to deobfuscate it in CyberChef. Walk through, drag the file in. Fantastic. Drag the XOR in with the key of ADR2 ... Right there, fantastic. You can see a little bit of a change happen there. Now we don't want hex because this isn't hex. This is a UTF-8, and UTF-8 is just text. And cool. So now we're going to save this output. We're going to save it as download.dat. That works fine. Fantastic. Go to downloads. There it is. Drag and drop this into here. And what we're going to do next is, oh, I need that back. We're going to take a look at this, and now we have the file here. The tool we're going to use is something called binwalk. And we're going to use the command .D to give the files an extracted, or we're going to extract files out of this .dat file and see if anything's there. And I'll bring up another source here. Binwalk. Binwalk is a tool for searching a given binary image for embedded files and executable code. And this just comes with Kali Links. If I go up here, binwalk, it shows up. So let's use the command. Binwalk, D, and the little star means look for any file in it whatsoever, and just and then run it against the download.dat. And if we run it, we'll see we have a PE, or a portable executable. We're going to CD into the downloads folder, and then we're going to get the MD5 hash sum from this, and there's our answer, the 3DFA337 . If we go back to here, we can see 3DFA7337 . Okay, so question 11. What are the two protection methods enabled during the compilation of the PE file, comma separated? Now this one is also actually really difficult because I had to go through a couple tools in order to even find this answer. So what I did was I first went to winchecksec. That didn't work. Couldn't get it to work. I went to PE Studio. That didn't work. I then went to PE Security. That tool didn't work. The tool I found that did work was actually PEV, the PE File Analysis Toolkit. This is why you do not give up, ever. Okay, so here's the file here. You can download it here. And what I've done is I've taken my file here, the 591, and I've moved it to my my Windows host. So this is it here, the 591.exe, and I've opened this up in PowerShell. And what I'm going to do is I'm going to run the command that is needed. So the pesec.exe against this file, and you will see that the answer is SEH. And now you'll see something here called stat cookies. Now I just had to Google this to figure out what this was. If we go back to here and we Google stat cookies, I know they look delicious, but these here, if we go to this link right up here, we'll see it here. This is the answer. The stat cookie is also known as a canary. It does not prevent the return address from being overwritten, but increases the chances of the code notices the override before fatally following the overwritten return address. Now this has something to do with buffer overflows. I'm not completely into computer science and understanding the memory stack, but I know that the SEH has something to do with the buffer overflow, as well as we can see here, buffer overflow protection, canaries. So if I were to try to reverse engineering this piece of malware, I'd start with some sort of buffer overflow, and that is the answer right here, the SEH canary. SEH and canary were enabled during the compilation of the PE file. Okay. Question 12. When was the DLL file compiled? Now, the way to find this is actually quite easy. We're just going to use the exif tool. And we don't need payload.exe. We need we just need this one, 591. And we will see that we are looking for the timestamp of when this was compiled. And it is right here. 2002-01-09. So if we go back to our question here, we just rearrange it so it goes month, day, year, and there is our answer right there. Question 13. A flash file was used in conjunction with the redirect URL. What URL was used to retrieve the flash file? So the way to find this one is actually very simple. You just go back to packet total, and it's not going to be in the first timestamp. It's actually going to be in the second one, because this one also has to. This also is looking at the different exploits, and network Trojan was detected. If we go to the second one, we're actually going to find the answer right here. HTTP refer. So addstairs.row.sfw is the correct answer. What is the web browser version of the infected host? So the way I found this one was by going into our Wireshark. Make sure we clear everything, go back to the top. And I'm going to filter out our host as well as the malicious host as well, which is this filter here. And sure enough, we see pretty much all we need to see here. If we search through any one of these, we go to hypertext and we can see compatible MSC 9. Now this is how I got the answer. How you get the answer is your own way. This is just what I happen to found. So user agent Mozilla compatible 9. Question 16. What is the DNS query with the highest RTT? So for those who don't know, RTT stands for round trip delay. And it is the amount of time it takes for a single signal to go to the receiver and back again. So what we're going to do is simply just look at this in Brim Security. And we're just going to search up the DNS. And then we're going to sort by the RTT. And we can just sort by the longest. And that is right here. If we take a look at what the DNS is, it's right here, ssl.gstatic.com. So this is the highest RTT. Alright, so question 17. What is the name of the SSL certificate issuer that appeared the most? One word. So what we do is we go back up to packet total, and we're going to go under this tab right here, the SSL certificates. And we're going to find the answer within the first tab here. And it's right there, Google. If we search other ones, we'll say Google, 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 Google. It's just Google. So that is MalwareTrafficAnalysis03. I have a lot of fun with this VR stuff, so I'm going to keep doing it. Yeah, I hope you guys have a great day, and thank you for watching. Bye.